Good morning, my dear students. So in this class, I'm going to tell you about we are going to solve some numerical problems on transverse vibration. Okay. So I told you what you mean by transverse vibration. So here the axis of the shaft which will be vibrate along the perpendicular to the axis of the shaft, that is called as what, transverse vibration. Okay. So here already we discussed about in the introduction class what you mean by transverse vibration and how the loads are acting on different different loads. Okay, that is a single load, or the several loads, or uniformly distributed load, or two force. Okay, so these are the some loads acting on the transfer vibration, that numerical problems we are going to solve in this class. Okay, so transverse vibration means what? Here the axis of the shaft which will be rotated, or which will be vibrate along the perpendicular to the axis of the shaft is called as what? Transfer vibration. Okay, so here in this class I'm going to solve the two numerical problems on transfer vibration. Okay, so first problem number 6 is, I'm going to read the question now. Determine the natural frequency of the transfer vibration. Okay, so I told you what you mean by natural frequency, and the free vibration of a, here what, determine the natural frequency. Natural frequency is equal to what? Nothing, what? The frequency of in free vibration is called as what? Natural frequency. Okay, that is, it is denoted by f of n. Okay, so here according to the Newton's second law, if you take any one particular shaft. Okay, so one end is fixed, another end is cantilever beam. Okay, if you consider the cantilever beam, based on that we are going to derive this equation, determine the natural frequency of the transfer vibration. Okay, so according to the Newton's second law, we know that what is the Newton's second law? That is force is equal to ma. Okay, so that is the inertia forces which is equal to the external forces. Okay, so according to the Newton's second law of masses, so mass into acceleration which is equal to what? The net force on the mass. Okay, so here the inertia forces. Okay, so here what is the mass? This is the inertia force is equal to what? Mx double dot. This is equal to the there are two forces will be acting on that particular element, that is a spring force and damping force. Okay, so that is mg minus k delta, that is mg minus k delta plus x. Okay, so again you simplify this, you're going to get what? This equation, that is m of x double dot, which is equal to mg minus k delta plus kx. Okay, but we know that k delta and mg which is equal to same, so that going to get cancelled. So remaining you are going to get this equation. Okay, that is what? Mx double dot, which is equal to minus kx. Okay, so again you have to write this k minus kx, you take this side. Okay, mx double dot plus kx is equal to 0. So here you divide by m, that is m going to get cancelled, you are going to get remaining is x double dot plus k by m into x, which is equal to 0. Okay, so but we know that k by m is equal to, that is m by k is equal to what? We know that is what? The omega. So this is not w, this is omega. Angular frequency is equal to what? Square root of k by m. So this equation we know that, so substitute here. Okay, so here hence the time period and the natural frequency of transfer vibration and the longitudinal vibrations are both are same. Okay, so in place of this omega is equal to square root of k by n, you replace here. Okay, so that is what the natural, that is the angular frequency. Okay, so we know that the time period is equal to what? That is t is equal to 2 pi by w. Okay, so we already calculated the w value, so just to substitute here 2 pi by w, in place of w you are going to substitute root k by n. Okay, so which is equal to what? We know that omega is equal to root k by m. Okay, if you simplify that you are going to get this equation. Otherwise this root of k by m, it goes to top, so you are going to get finally 2 pi divided by square root of m by k. So this is the time period of the given transfer vibration. Okay, but we know that mg is equal to gravitational force is equal to deflection spring force. Okay, so here k by m, so this is k by m is equal to what? J by delta. Okay, so we know that the natural frequency is equal to what? The reciprocal of time period is called as natural frequency. Okay, so f of n is equal to 1 by t. So already we know that the time period is equal to be calculated here, just to substitute here. Okay, that is 1 by t 1 by 2 pi square root of k by m. Okay, which is equal to 1 by 2 pi square root of j by delta. Okay, so this is the natural frequency of the given transfer vibration. So you have to remember this 1 by 2 pi square root of j by delta is the natural frequency of this transfer vibration. Okay, but and we know that the g value, that is the gravitance, that is g is equal to what? 9.81. Okay, so square root of 9.81, you are going to get this equation. Okay, you can use this equation or this equation, both are same. Therefore the natural frequency of f of n is equal to 0.4985 divided by square root of delta, where delta is equal to what? The static deflection produced in the load. Okay, so this is about the natural frequency of the transfer vibration. So many times they may ask in the examination, determine the natural frequency of the transfer vibration. Okay, so according to the Newton's second law, mass of the acceleration which is equal to the net force of the mass. Okay, so substitute all the values, you are going to get the final value, that is natural frequency is equal to what? 1 by 2 pi square root of j by delta. Okay, so if you again you simplify this, you are going to get the natural frequency is equal to f of n is equal to 0.4985 divided by root delta. Okay, so this is the natural frequency. Okay, so the next problem is very important here, the problem number 7. So I will read here. This is also very important for the point of examination. Okay, so a shaft of the length 0.75 meter supported freely at the ends and is carrying about a body of mass 90 kg at a 0.25 meter from the one end, and find the natural frequency of the transfer vibration. Okay, so assume E is equal to, that is the Young modulus E is equal to 100 giganewton per meter square, and the shaft diameter is equal to 50 point, that is a 50 mm. Okay, so here the length of the shaft, that is here the length of the shaft is given, upon which at the middle the force is acting, that is 90.981. Okay, that is 90 newton. So you have 90 and that is 90 kg. If you convert this into 90.90 into 9.81, this is the into, not point. Okay, so exact metal one force is acting. Okay, so here from the point A, so at a distance of 0.5 meter one force is acting, and from the reference side at a distance of 0.25. so this is a question given in that this is two values are given in the question. So according to that question you are going to apply the force here. Okay, so from this point to this point called as what? A, and from this point to this point is called as B. Okay, so the total length of the shaft is given, L is equal to 0.75 meter. Okay, so this is about so first step is to determine the natural frequency of the given transfer vibration. That is your aim. Okay, so first step is you find the write down all the given data here. Okay, diameter 500 mm is given, so you have to convert into meter, that is you just divide by 1000. Okay, so next, length of the shaft is given 0.75 meter, and mass is given 90 kg, so you have to convert it into newton. Okay, 90 into 9.81. Okay, so now so I wrote here, so Young modulus is equal to what? 200 into 10 to the power of 9 newton per meter square. Okay, so these are the given data given. So based on this given data we need to find out the of natural frequency. Okay, so but we know that we know that the deflection of a beam, okay, exactly middle. Okay, so we have the deflection formula is equal to what? Delta is equal to W, that is weight A square B square divided by 3EIL. Okay, so this is a formula for simply supported beam. This is the formula for using when there are two forces without any fixed point. Okay, during such condition we are going to use this formula. Okay, so we know that weight, you know, A square, you know, B value, you know, 3 know, E know, I know, you know, everything we got here. Okay, so where I is equal to moment of inertia. Okay, moment of inertia formula is there, that is here W weight to 9 point that is 90 into 9.81 into A square is 0.50 whole square into B square is 0.25 whole square whole divided by 3. E means 200 into 10 to the power of 9. Okay, into moment of inertia into 0.75, right, as it is. Okay, again you have to simplify, but moment of inertia I is equal to what? Pi by d square. Okay, so that diameter is given 15 to 10 to the power of minus, just to wherever I is there, just to substitute pi d square. Okay, that is pi by d square. Okay, that you have to simplify. So you substitute there all the values, you are going to get the deflection is equal to 9.992 into 10 to the power of 5 meter. Okay, so this is the deflection, but they are asking what the natural frequency. So natural frequency is equal to what? F is equal to, that is f of n. Okay, so you write here f of n is equal to 0.4925 square root of delta. Okay, so delta already we calculated here, delta substitute here delta value, so that you are going to get the natural frequency for this particular shaft. The given problem is 49.86 hertz. Okay, so frequency is measured in hertz. Okay, so like this you have to solve the problems. Okay, so here this is the shaft. Okay, transverse vibration shaft, upon which there are two forces are acting. Okay, that is several forces are acting here, 1 2 3. Okay, these are the reaction forces, but this is a single load. Okay, so in this problem you have to remember only this formula. Okay, one formula, this is delta is equal to W A square B square divided by 3EIL. Okay, and the F is equal to 0.4925 by delta. Okay, so this is very important for the solving the problem. Okay, like this you have to find out the transfer vibration problem. Okay, so first one is to find the natural frequency, that is according to the Newton's second law, and second one is the problem based on the that is the shaft. Okay, so here the main thing is what you want to remember is the natural frequency is f of n is equal to, you have to remember this formula. If they given in the question in place of, that is in terms of delta, so use this formula. Okay, so that is 0.4985 divided by square root of delta. Okay, suppose they are given in spring mass, then use this formula, 1 by 2 pi is equal to square root of k by m. Okay, so these two formulas and the natural, that is the deflection formulas. Here there are two formulas, delta is equal to W A square B square by 3 IL. Okay, this formula, in this formula you have to remember, okay, to solve the problems on transfer vibration. Okay, so it's very important. So they may ask you, this looks like very silly, but you have to remember the formula. They may ask you around 4 to 5 more question. Okay, so I think you understand these two problems. That is what the natural, that is what the natural frequency of the transfer vibration and the problems on transfer vibration, that is a single load acting on in a normal shaft. Okay, so here what you mean by, so once again I will repeat, the transfer vibration is nothing but what, the shaft which is rotated, which is vibrate or which is rotated perpendicular to the axis of the shaft, that is called as transverse vibration. Okay, so longitudinal vibration is different. Okay, so for your syllabus only the transfer vibration is there, that is a single mass, several mass, uniform distributed load. Okay, there are three different types of problems you can solve in the transfer vibration problem, in the transfer vibration. Okay, so I hope you understand these two problems. Okay, so this as compared to these two problems, first problem is very important. Okay, so you have to perfect that problem. Okay, so I hope you understand these two problems. Okay, thank you very much.